Let's move into the next section for algebra 1. So we're going to actually go through some of these things and make sure that we can solve these. So we're going to solve some quadratic equations by graphing. And sorry, this is algebra 2. So anyway, so first things that we're going to look at is finding intercepts. But before we get there, I just wanted to kind of point out something. In the presentations, which I think are important to take a look at, if you are having any difficulty, of course, watching the videos are important, but what you'll notice is at the beginning, I have a lot of examples that are up here that the book has solved and that you should go through and you can check your answers. So you can go ahead and look at those. So here you have a solving, kind of gives you the steps that you have to go through. So you can look at these pieces and see them. I'm going through examples that are, of course, like this, but I'm doing them without all the answers being right there on the resource itself. So make sure you take a look at those resources if you have any questions and need more examples. So we're going to go ahead and go through the warm-up. So the first thing that we're going to look at is trying to find the x-intercepts of each function. So notice this x-intercept right here is -4, 0 and +2, 0. This one is -1, 0 and +4, 0. You can see here we have -1, 0 and +1, 0. But you can go through those and you can also check what the answers are. So that way then you can see what they are when you're looking at these particular values. So that's going to help us once we start doing some of this graphing. So what we need to learn first is some of our vocabulary. So some things that we need to know. What is a quadratic equation? A quadratic equation includes a quadratic expression. That just really means what's more important is that it has an x to the second power, an x to the first power, and a constant. But some of those can be 0 except for the x to the second power. Standard form for the equation, ax squared plus bx plus c equals 0. A cannot be 0, obviously, because if a is 0, then it's a line. A, b, and c are integers, but as I just mentioned about this quadratic equation, b and c can be 0, because as long as you have an x squared term, it is okay. So the first thing that we're going to take a look at are roots of quadratic equations. Roots are just solutions to the quadratic equation, or they are x-intercepts, and that's what we went over in the first warm-up, is looking at the x-intercepts. So we want to figure out, okay, what are the x-intercepts here? So if we were to graph this, we could see that it looks like a parabola, and we can see right here where it crosses the x-axis. So at -3, 0 and +1, 0, those are what is known as our roots. So there are roots right there. And that's what we have for those particular pieces. For this one, same kind of thing. We graph it. This parabola is going down because of this negative in front. So we have a root at 1, 0 and another root at 6, 0. This one is going up. So if we were to graph this one, notice we have, again, at -2, 0, +3, 0. Those are our roots that we have for those. Okay, and that's just kind of giving you an idea of what roots are. Okay, so just looking at these, so again, before estimate the zeros, we already did that, and we went through all of these pieces, I believe all of them, just kind of give me what the exact values are. So, and how can you check to see? We can always factor this, graph it, of course. Graphing is what we're dealing with in this particular one, but there's a number of different ways that we eventually can figure it out. Now, are the zeros solutions? Yes, remember that roots and solutions and intercepts are all the exact same thing. So that would be true. And then as we go through the rest of it, let's see what else it's asking us. This is for the second one. Remember, this function in this particular case is a parabola that's going down, and we can figure out all those things as well. Okay. Solving quadratic equations by graphing. So what we're going to do is we're going to look how to graph this and see what is a good way to do it. So we have ax squared plus bx plus c equals 0. Of course, a cannot be 0. Here are a couple examples of quadratic equations. So notice here it says one method for finding the roots is to find the zeros. We can identify the solutions or roots of the equation by finding the x-intercept. So notice that I've already used all these terms. So solutions, roots, zeros, all that stuff, intercepts, all mean the exact same thing. So I can go through and try to figure out where they cross. Of course, we would have to plot this to figure this out. It's not just intuitive. Eventually, we're going to start learning how to factor and see what those particular roots are. So that's really what we're looking at when we're finding these, okay? So notice it says that exact roots sometimes can't be found. So notice in this case, if we have our function of x, remember, of course, our y value is always 0, where we find the roots or the x-intercepts. Notice that in this case, if we were given a table and we didn't have a 0, we know that a 0 has to be between 1 and -1 because it has to cross over the x-axis at that point, and then it has to cross back over the x-axis. If it's a parabola, it has to cross back over the x-intercept in that case. So we would have a 0 somewhere here and a 0 somewhere here. And so we would estimate those as we're going through there. And then what we want to figure out is how many solutions does it have? And that's something that we will start determining. And we're going to base that on, if you recall, we're going to base that on the axes of symmetry. So that will help us out once we get to that point. Okay, so first thing that we're going to do is one real solution.